Hello friends, in this video we are going to solve a problem called non-decreasing array. So in this you are given a one-dimensional array of numbers, and the numbers can be increasing, decreasing if you scan the numbers from left to right. So the thing is that you have to make it non-decreasing. Non-decreasing can be either increasing or equal to. So even if all numbers are same, it's still non-decreasing, but it should not decrease. It should remain flat or increase. So you are allowed to make just one change to the numbers. So you can increase any of the numbers in the list, or you can decrease any of the numbers in the list, but there should be just one of that at most. It may be already a non-decreasing, so in that case we return true. If it's not non-decreasing, we will see if by changing one number we can get it working. So let's take a couple of examples. So let's say we have a sequence 8, 5, 7. So we can plot it. 8 is some higher value, then 5, so it decreases here, and then 7. So 7 is more than 8, less than 8, but more than 5. So it will lie somewhere here. So this is not a non-decreasing array because it decreases here. So what we can do, we can decrease this 8. So push it down below 5. So this is 8, 5, 7. So if we make it 5 or less, then it's fine. So we can make it 5, 5, 7. So we change just this 8. So one change is allowed. Now if you look at this example, so 8, then 5 is here, then 2 is further down. Now there is no way we can make it non-decreasing by just changing one of these numbers. So let's say we decrease 8, because this is the place where it's decreasing. So when we have a decreasing sequence, this is what we have to eliminate, this kind of lines. So either we drop it down or we increase it. These are the only two ways. So let's say we make 8, 5. So we got 5, 5, 2. Now still it's decreasing here, so this is invalid. Now let's say we increase 5, because these are the two ways, method 1, method 2. So now 8 is constant, 5 we have to increase till it becomes non-decreasing. So at least we have to increase till 8, and we are allowed to make just one change, so we get 2. So again this is not a non-decreasing array. So with just one transformation we cannot change this array to non-decreasing. So in this case we have to return false. In this case we have to return true. And if it's already increasing, let's say 8, 10, 12, again we have to return true. If it's 8, 8, 8, again it's true. So now you get the idea. The problem is clear to you. Now let's see how we can solve it. So we will use diagrams like this so that it's clear. We don't have to worry about actual values. So we can look at the diagram and say whether it's increasing, non-decreasing or not. So it can be flat, but it should be increasing or flat. So now let's see different cases. So first of all, list down all the valid cases. So let's say we have a case where it's flat completely. So this is true. Then we have a sequence where it's increasing. It's also true. We have a sequence like increasing, flat, increasing, flat, increasing. This is also valid. So in these cases, when we scan the array from left to right, we will not encounter any decrease in value. So how to check a decrease in value? Let's say we are at index I and we compare it with previous value, and let's say this is A. So if AI is less than A of I minus 1, then we hit a case where it's decreasing. So we can keep track of at what indices it has decreased. So in these cases we will not find any such cases. Now let's look at the cases where we will encounter such cases, but those can be transformed. So first case would be that it's increasing, flat, maybe it decreases, and then next value it increases, and then further it's increasing or non-decreasing. So this is one case. So we have just one deviation. So if we count, we look at all the intervals, all the set of pairs, immediate pairs. So here it was increasing, flat, flat, decreasing. So this is the one point where we got this anomaly. So we note this index I. Then again it's increasing, flat, increasing. So we will just store this value and count is 1. So at any point of time, if we have more than 1, straight away we can return false, because we cannot correct two decreasing pairs by just one transformation. So it can be decreasing like this. So there is no way. We saw this example. So this is the simplest of examples where we have two decreasing pairs. We can have more complicated where these are not back to back. It can be like decreases, then increases, 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 and then again decreases. So you can correct one of these by changing it in this region, but this will still remain. If you change in this region, this will remain. So if we have two or more such indices, we return false. So now let's look at the cases where there are just one decreasing pairs. So it's very simple. You see, you just scan through this array. As soon as you encounter this situation, and as soon as the count becomes 2, you return false. No need to scan the remaining array. So this way you save some time. You make it more efficient. So now you see these are trivial cases. If count is 0, it's fine. Count is 2, it's also fine. These two are trivial cases. In this case it's false. In this case it's true. So we are only worried about the sequences where there is just one decrease. In some of those we can make it non-decreasing, in some of the others we cannot. So let's list down possibilities. Another possibility, so you see that here if we make this index somewhere here, so before this dip the value was at this point, after this dip it's higher than this, it may be equal, that should also work. So if we increase this here somewhere in this range, then it will become non-decreasing. So this is fine. This is the true case. Next we have, let's say, the same example, but instead of one dip, let's say we have this increase and then it decreases and then increases back again and so on. So in this case it's a very mirror image of this. So we have to decrease it. So here we had seen that there are two ways of making the pair correct. Either decrease the first one or increase the second one. So these two cases correspond to that. So here this is the index I. So we will decrease this value before I. So this will be corrected. Now the third case is we have, let's say, so we are looking at only the cases where there is just one mismatch. So again this is the decreasing pair, all other are increasing. So if it's a trivial case, index is 0, so we can decrease it any value smaller than or equal to the first value, the second value. And equivalent case would be in the last index. It's increasing, but in the end it decreases. So here also we can increase it to any value we want. So we have 1, 2, 3, 4 cases. Next we can have a case where it's let's say increasing, non-decreasing till here, then we have a dip, a big dip, and then increases and keeps on increasing. So it's very similar to case 1. This is case 5. it's similar to case 1, but in case 1 these all are true cases, but in this case it's false. So in case 1 what we did, we increased this value to lie between the previous and next. Here the previous is and next are in blue color. So next is less than previous. So no matter where we put this, if we put it here, it will still be decreasing. If we increase it, this will be increasing, but then we will have a decreasing value. If we keep it here, then this will become non-decreasing, but here we will have a dip. So this is the false case, very similar to first case. Now we will have cases where we have multiple dips, but as soon as we hit that case, we return false. So that's very trivial to write in the code. 0 dips or 2 or more dips, those are trivial. We are worried about 1 dips. So what? Let's list down all the cases. So what happens in case 1? So this is index I. So we will make AI. So this is AI equal to AI minus 1. So whatever is the value previous to I, make it that value. Now it's increasing. So for that, what is the condition? That AI minus 1 should be less than equal to AI plus 1. Then it's true, otherwise we will see what happens. So this is case 1, pretty simple. Next is this one. Here so here we have to decrease this. So here the I is this value. So what we will do, AI minus 1, change it to AI, and we are done. Next we have this one at index 0. So straight away, if count is more than return false, if count is 0 return true, if else case, that means count was exactly 1, that is count is 1. So when count is 1, we record the index also, and by index we mean this. If index is 1, that means this case, the first value. So this is index 0, 1. At 1 we check this and we found it decreases, so we note this 1. So if index is 1, return true, because count is 1. Count is 1 already, so this is the only place, so we can decrease it. Similarly, if index is n minus 1, return true, and then we will have the remaining cases, these two cases, and then these two we have covered, and then we have, this is the case very similar to the first case. So here previous is more than, so AI minus 1 is more than AI plus 1. That is the case here also. AI minus 1 is more than AI plus 1. So these two cases we have to write carefully. So now we are at an index I where there is a dip. That means AI is less than AI minus 1. This is the condition when we noted this index I. So we had two conditions. One is that AI minus 1 is less than AI plus 1 or equal to. So this is the good case where it's true. So in this case, return true. Else these two cases, case 2 and case 5. So let's just draw so this is case 2. So in both cases you see that so let me draw this a bit higher like this. So here we decreased it to this level and it was fine. But here if we decrease it to this level, it will be, this value is already higher than these two. So or rather here we increased this value. Okay, we decrease this value, and here we cannot decrease it, it will become a decreasing sequence. So if we try to increase it here, then again it will be decreasing. So the two cases would be that, and the other one would be let's keep it as it is. So we decrease it and then flat and then increasing. Both cases are wrong. So how to distinguish between these two? So this is the index I in yellow. This node is I. Here this node is I. And previous is more than next in both cases. But here what will happen? If a I minus 1 I minus 2 is more than a of I. So you see that here this I minus 1 is more than a of I, that's why we had noted this index, but its previous was also less than this. So in that case it will fail. We can neither make it here nor here. In both cases it's false, because this is the case where ai minus 1 is more than ai plus 1. And in this case what will happen? ai minus 2 is less than equal to ai. So these are the two cases. So we will see it in the code. So these are all the cases, and depending on that you can return true or false. So let's write the code. So first I will write in C++, then we will also see it in Java and Python. So this is a base case. It's already given that n is at least 1. So if n is 1, it's already non-decreasing. So return true. Then this index we will capture where is the dip, where is the decrease. So this if this is 0, if this is not 0, then that means we have already encountered a dip earlier. So this is the second dip we are seeing, so we return false. And we capture the index. We will never capture it twice. Now, so as soon as we hit 2 dips, we return false. So if we go beyond this loop, that means there was just one such decreasing pair. So now we will handle all the cases. So if 1 or 0, so if idx is equal to 0 or idx is equal to 1 or idx is equal to n minus 1. So we have covered all the trivial cases. So 1 corresponds to this value where the leftmost, the first pair is a dip. So we decrease the very first point, and the second case is this n minus 1, then we increase the last point. And the other cases are where we don't encounter any such value and we encounter 2 or more values. And finally we handle this case, this 2 and 5 cases, case 2 and case 5. So this case is already true, so we don't need to handle it. In the end we will return true from the function. And we are done here. So what is the time complexity here? So let's see. We scan through this list, this array once from left to right, so it's O of n, and then we exit as soon as we encounter more than one pair of dip. So and finally we after that loop we just compare a few values, ith value, before that, next, and maybe previous. So it's overall O of n space, it's O of 1. We are just having a couple of variables for index. And the solution is accepted. Next we will do it in Java. So the Java solution is also accepted, and it takes 0 milliseconds, so it's quite fast. Finally, we will do it in Python 3. And the Python solution is also accepted.